Hello and welcome to this video, and what we're going to do is talk about some of these polynomial models that I know you guys love so much. Everyone always loves the word problems, right? So we're in your lab manual and we're going to look at this problem first with the shipping box. And one thing you need to first understand is what they're talking about when they mention girth, okay, and that's your distance around the box, okay? So you can see the arrows down here. You got to go all the way around that whole box, okay? So if this side is x and this side is x, then obviously this is x and this is x, right? It's a square, and your girth, okay, is going to be 4x, all right? Because you have to go all the way around all four sides. And then it also talks about the length plus the girth. It cannot exceed 108 inches, okay? So if we call our length y, okay, then that means 4x plus y must equal 108, or you can think about it as being less than 108, but in this particular situation, they do say assume all 108 inches are used, so it would be appropriate to put the equal sign. Okay, so what we're doing now is we are setting up some algebra, okay, to represent the situation, which will help us to figure out the answer to some of these questions down here. So part A, it says what is the length of the box if its volume is 2,200 cubic inches. So they're giving us a specific volume. Okay, and they're saying, hey, if we need this volume, okay, and you obviously have to work with this 108 inches, what length can we use, okay? So let's remember how volume works. Volume is always length times width times height when you have a rectangular prism like what we're dealing with here. And when we're setting up our volume, we want to make sure we only have one variable. Okay, and what I mean by that is you do not want to get stuck in a situation where you're using your x's and your y's. Okay, so what a lot of students will do here is they'll say volume will equal x times y, right? And what they're looking at is they're looking at their let's see, length, width, and height. Sorry, my cursor's not cooperating. But if, you know, your three dimensions of your box, right? So, okay, if you're calling y your length, then this x here can be your height, and this can be your width. And so they're thinking of x times y, okay, as the volume. Well, this is using x's and y's, and we only need one variable. We can only have x's or we can have y's, okay, but we can't have x's and y's. So what we have to do is a little maneuvering. So if you come back over to this equation over here, I can subtract that 4x over, and I can get this 108 minus 4x. Well, what that allows us to do is it allows us to replace the y, anytime you want to use a y, with 108 minus 4x, okay? So if we go back to this thing that you were trying to do over here maybe, is instead of putting a y, you can put 108 minus 4x, okay? So let's set up our volume, okay? So I'm going to call this v of x, okay, volume in terms of x. And we're going to have our x times our 108 minus 4x, okay? Length times width times height. And it really doesn't matter which one you're considering length, width, and height. It's just you got to make sure you're multiplying the three dimensions together. And they give us a specific volume of 2,200, so we'll put that in. And then this, you can think of this as being an x squared, and I'm going to go ahead and distribute that x squared. So I'll have 108x squared minus 4x cubed. Okay, and now what we have is an equation, obviously, and it has a degree of 3, right? Your highest exponent here is 3. So let's get this in standard form. I'm going to put the negative 4x cubed in the front plus 108x squared, and then I'm going to subtract that 2200 over, and then I'm going to have it equal to 0. Okay. Notice we are missing a term in here, right? Think about back when we did polynomial long division and you would have to put in a placeholder, right? Okay, same idea. We are missing a term, but that's okay. So what we have here is a third degree equation that you cannot solve by factoring. Okay, so what we allow you guys to do on these types of situations when you don't know the algebra to support that is we let you use your calculator to solve. Okay, and here's one of the reasons you're going to start loving this calculator, and you want to go into your PolySolve, which is your second cosine button, and then you will see two options come up here, and we want to use the second option, which is the third degree. So I'm going to arrow down and then hit enter. All right, and now they're asking for an A value. Okay, so I'm going to go back here and point some things out here. Let's see, where can I write this? This is going to be, okay, this is going to be our A value, -4. This is going to be our B, which is what's with the x squared. And we're missing the term. That's going to be the C value. And then this last one here is going to be the D. Okay, so let me get back to the calculator. All right, so I'm going to put in a -4. Okay, and hit enter. And then it's asking for the B, which is the 108. Hit enter. Okay, and then C is 0, so I'm going to leave that as 0 and hit enter. And then my D is -2200. Okay, and hit enter. All right, and then you can see the option of solve comes up here, right? You see the solve. Okay, so I'm going to hit enter. And the calculator is going to give you some outcomes. So I'm just going to jot these down, okay? So I have x sub 1. Let's see, go back to the pen here. Okay, so x sub 1, it's giving me 26, and we'll just go 3 decimal places, 0.199. Okay, and our unit here is inches, by the way, since they introduce inches in the problem. Go back to the calculator, and remember this is a third degree polynomial, so we are looking for 3 solutions just like we've done in the past. So I'm going to arrow down and it'll tell you the second solution is 5. Okay, so x sub 2 equals 5. And then let's go back to the calculator to see our x sub 3. And that is -4.199. Okay, I think, let me pull the calculator back up here and look at that again. Yeah, if I round to 3 decimal places, it'll be 0.199. Okay, well, remember that x represents the length of the box. Okay, right? It's an actual dimension of the box. So it's not going to make any sense to have a negative number there. So that's an extraneous solution. So we can not consider that. But what we did get are 2 solutions that we need to consider here, okay? And a lot of times students think when they do word problems that they can only get one answer, okay? And they always think that there's only one answer to every word problem. Well, that's not necessarily true, okay? When you get into your higher level math, sometimes there will be multiple answers that you can use, and you have to consider those as possibilities, okay? So I'm going to kind of continue down here where I have a little more space. So if we go with the x sub 1, okay, then that means we will have 26.199 inches as one of our dimensions, right? And if we use that, okay, as the value for x, then we can calculate that length, right? The length is going to be 108. Okay, right, go back up to the sky here. 108 minus 4 times x. Okay, so since I've got the calculator going here, let's just type it in. Okay, so 108 minus 4 times okay, sorry, this thing does not cooperate as good as the actual calculator. 4 times, and I'm going to put in the 26.199. All right, and I'm going to hit enter, and I get 3.204. And that'll be inches. Okay, so this is the possibilities for that box. Okay, if I go with using that first X answer. Okay, if I use the second X answer of 5 inches, okay, then my length is going to be, all right, just go back to your calculator. And we're going to just basically do the same thing here, except for we're going to use a 5. So it'll be 108 minus 4 times 5. Hit enter and you get 88. Okay, so that would be kind of a long skinny box, I guess is how you can think of that, right? Which would work well if maybe you're shipping, say, blinds or, you know, something long, you know, that needs a long skinny box. But if you need a box that's a little bit more well-rounded, maybe you could go with the other option. But both of these, okay, both of these would give you a volume of 2,200. Okay, so those are both possibilities if you specifically need that volume. All right, then in part B here, they're telling us to go down to Desmos and determine what is the maximum volume possible. Okay, so in part A, they were giving us a specific volume to use. In part B, they're just wanting us to think about the function in general. Okay, so I'm going to go back to that v of x function where we had not put in the 2200 yet. Okay, and we just want to think about this particular graph on Desmos, and I believe I've already got it keyed in here. So I did not use V, I used F in Desmos, as you can see here. But then I put in the function, and here's the graph. Now I did have to go into settings, okay, just so you know, I did have to go into settings over here, and I had to adjust my X and Y values a little bit so that it would show this full graph. Okay, so that takes a little bit of maneuvering to get things like you want it. And then you can see over here where I was just looking at some different values for the function. So f of 10, if I put in a 10, I get a 6,800. So like you can see, that points right in here somewhere. There we go, 10, 6,800. So that would be, if, you know, a possibility, right? If I can get back on it there. Whoops, too much coffee today, right? That would be if I need that volume, I could use that X value. And then I could, if I wanted to use an X value of 22, then I could get a volume of 9,600. Okay, so you want to go to your 22. See if you can, there we go. And that would be a possibility, but those are not the highest, right? Your maximum volume is going to be right here, okay, at this turning point, right? We've talked about that a little bit, right? It's increasing and then it's decreasing, and so we have this local max right there, okay? And that would be if we use an X value of 18, okay? So we'll go back to this, okay, and it says sketch the graph. So here's where, if I was you, I would add a quick sketch to your notes to show that you did that. Okay, and then you could label this point here, and it was 18 and then 11,664. Those were the two values of that maximum point there. Okay, and that is going to be your maximum volume possible. And let's just put a unit in there. This is going to be cubic inches. Since we're in inches and we're doing volume, it's going to be cubic inches. And Once again, remember that's not the only volume that's possible. That would be the maximum volume. So let's say that maybe it really doesn't matter what the dimensions of the box are. Okay, maybe they just need the maximum volume. Like for example, maybe they're shipping, say, ping pong balls, okay, something that's kind of small. And it really doesn't matter the shape of the box, okay, because ping pong balls are so small they're going to kind of fit in whatever. But they just need the most volume possible so they can ship the most ping pong balls possible. Okay, just trying to help you understand the situation. So a company would be interested in this information so they can figure out what types of boxes they should use to ship out their product to maximize the volume and maybe minimize their cost as far as paying for the cardboard and the shipping and that kind of thing. All right, so that's one example. So let's go over to the next page and we'll work another one together. So this one is a woman's going to create a garden on the back of her house. Okay, and so let's draw a little picture here. So this will be the house. Okay, so this is the house, and on the back she's going to do a garden. All right, and I'm going to intentionally set this one up a little different than the answer key because I want you guys to see something that's very important. The answer key is just going to be one version of how you can set a problem up. And a lot of times there's different ways you can establish your variables, okay? And so I'm going to do that here to show you. So I'm going to let these sides over here be x, and I'm going to let that side be y, okay? Now she's going to use 100 feet of fencing, okay, so 2x plus y equals 100. And remember, we only have 3 sides. Be careful here that you don't think 2x plus 2y, because we only need 2x plus y equals 100. Her house is going to be that 4th side. And then that means that the y can always be 100 minus 2x. Okay, so if we write a function that models the area, okay, and this is going to be a of x, remember we have one variable. Think about how you do area of a rectangle. Okay, well, area of a rectangle is always length times width, right? Area is length times width. So I need to use x and I need to use 100 minus 2x. Those are my 2 dimensions. And remember that we don't want to use the y, right? Because we don't want to have x's and y's. So, you know, if you've got x times y, you want to make sure you replace the y with that 100 minus 2x, which is what I've done over here. And then we're just going to fix that real quick. Okay, then we're going to just clean this up algebraically. So it's going to be 100x minus 2x squared. All right, and this is a function that models the area of the garden. Okay, now the next part it asks you, what is the domain? Okay, so you have to think about like what's going on here, and some of the situations are a little silly. But you could have, right, she could have her house here, and she could use like 1 foot, okay, I think we're in feet here, aren't we? Yeah, we're in feet, 1 foot, and then she got a really long skinny garden, right? So she's using 1 foot here and 1 foot here, and then she would have 98 feet left for that. Okay, now that's not going to probably be a very practical situation, but I guess if she wanted to do that, she could. Okay, or she could make it a little bit wider, right? So she would have 2 feet here, 2 feet here, and that would leave her 96 feet that way. Okay, maybe if she just really wanted a very skinny garden, she would do that. But you can see here that we can keep doing this, right? We can say, okay, let the sides be 3, let the sides be 4, let the sides be 5.2, let the sides be 10.6, and we could keep going and going and going all the way up to 100. Okay, so your domain here is going to be between 0 and 100. Now she can't actually use 100, she can just go up to 100, because if she uses all 100, you know, for this side here, you know, that's we're going to have a problem there as far as you've used too much on that side or whatever. So you have to think about the possibilities of what you're working with, okay? As far as you only have 100 feet of fencing, okay, but you also have to make 3 sides, okay? So it's kind of like common sense. I'll move on now. And then this says, how can she maximize her area? So maybe what she wants to do is just make sure she has the most space possible for her garden, which I could see someone wanting to do that, right? And so you're going to find your vertex. I'm going to rewrite the function in standard form. And then we know how to find a vertex. We've been finding vertex for a long time now. All right, and so you're going to get 25, okay? And that is saying, hey, if you use let's go back up here. If you use 25, okay, for this part of the rectangle, then you're going to maximize your area. So what's going to happen is she's going to have something like this, right? She's going to have 25 here, which means this side would also be 25, and that would actually leave her 50 feet there, and that would give her the most area, okay? And so this would be something obviously interested in if you're trying to maximize the amount of space you have for planting your vegetables in your garden, okay? So she's going to go with 25 feet by 50 feet, and those are the dimensions that maximize the area. So what I wanted to kind of help you see as model in front of you is I'm drawing out pictures, right? I'm thinking about the situation, okay? You're having to pull in a little geometry information to kind of get the ball rolling, and you're going to see that happen on pretty much all of these problems where you're, like I said, you're having to pull in some geometry, but you have to think about these, okay? So I encourage you, draw pictures, label pictures, try different things. If you don't know, if you can't remember how to find the area of a circle or whatever formula you might need, just Google it, right? And just look it up. But the idea here is you're going to set up some type of function, okay? And if you can, if we know the algebra to solve that function, then obviously show the algebra and demonstrate that. But if you have a function like what we had here, that's something that you guys don't know the algebra for, it is okay to use that polysolve on your calculator.